Hey, welcome back. Good to see you again. Glad you can join. Today on the bench I got a Harman Kardon HK350i. This came in with the other group of HK receivers and that Kenwood. And this one has, I asked the owner what the problem was with it. He was kind of unspecific. He says it's got a scratchy channel. So I'm just going to test it out here. I'm trying it out and it seems to be working. We've got FM. Picking up everything. FM seems to be working just fine. We do have a burnt out pointer lamp.
This one's perfect. Chaining up in the mountains, someone swapped.
But I got left and right working great. Controls are clean, they're not scratchy.
Then goes on to say, then the state pulled up to me about chains. So there are chains.
I think that's good.
Depending on certain states in the United States, you maybe get for it if you're. That's pure speculation.
But that's like that exact thing about you already know it's a problem. You can't do what you need to do.
And the state trooper rolls up.
AM.
As employee absences due to COVID-19 protocols is about.
Everything's working good on AM.
Is 19 minutes after.
Let's try the auxiliary. I got a tone fed in. Some kind of a DC thing going on with the bass control. We'll look into that. Maybe a tired cap. Left and right. Left sounds whiny. Right sounds good. I'm wondering if there's distortion on the left side. Try the Phono. Can tell we got a problem with the Phono amplifier. Let me feed a signal right into the Phono stage, and then we'll see what that sounds like. Give it 3 millivolts. One millivolt. Yeah, there's something going on with that left channel. Here's the right. It's clean and steady. The left is distorted and fading in and out. Okay, so I have an idea what's going on here. All right, there we go. Nice and clean. And what do we got going on here? Don't see much. I see those green TK capacitors I don't like. They're a problem. So we can remove some of those and test them. And if that's the case, we'll get rid of them. Circuit glue on the Phono stage here. Across these capacitors. Maybe that's what we're hearing. Maybe that crap from the glue is causing a problem. I might have to remove all that. Don't see anything burnt up or dark from heavy use. Everything looks good. Alright. Let's, before I go any farther, I want to hook up a scope and confirm that noise I'm hearing in the left channel is just not my burnt out speaker, and it actually is producing some kind of distortion. Let's hang on here. What's going on with this? This side's warm. This side's cold. So we probably have an imbalance on that too. Yeah, this side's cold. This side's warming up. And it's only been on for a few minutes, so probably the bias is way out of whack. So maybe we do have a problem with the left channel in the audio amplifier. Alright, so let me get a scope hooked up. I'll have a look. Okay, I got scope on channel 2 and speakers on channel 1 still. Feeding it the 1000 Hertz tone again. we got that whiny noise and whiny distortion in the left channel. Right channel sounds good. Okay, so let's turn the scope on. Let's turn up the volume. I got this set for both channels. Okay, and we can see we got some heavy distortion on the left channel. It looks like, yeah, it's not looking good. Alrighty, so we have a problem in that channel. Let's try square wave and see what it does. Yeah, we're not even getting full output on the left channel. Alright. Let me turn up the frequency here. I want to see what it looks like. Let's try 15 kilohertz. Yeah, same thing. We've got a buggered transistor or something going on. Could be a cold solder joint, could be a buggered transistor. But at this point, we know it's got a problem. So okay, let's open it up, take the bottom off, and I'll start poking around with my diode checker and check these transistors. See, this side's still cool, this side's warming up. Not hot, but it's still warming up. So I'm wondering what's going on this channel. Alright, so I went in and I was doing some poking around on this side. I was looking for the problem with the left channel. But dummy I am, I didn't even look at the schematic. And if you look at the schematic, the left channel, if you follow the lines around, this is the left channel on top here. And you'll notice that Harman Kardon uses even numbers for all the parts on the left channel, odd numbers for parts on the right channel. Kind of like car manufacturers when they do left and right on a vehicle, they have different part numbers and one side's odd, one's even. But here I was checking on this side, the odd side, and this is the good amplifier, and I was getting kind of frustrated why I'm not finding the fault here, because you know, it looks like it should be there, but dum-dum. Yeah, so I'm going to check this side now, and I haven't poked around here yet, so we're just going to do some diode checks on some of these transistors, and we're going to see if we can find the fault. So I got my meter out here. Let's test some of these transistors. I have a feeling it's probably one of these three. Just a gut feeling. So let's try this. Okay, it's not that one. Going on here. This is it's an PNP transistor. Okay, get this right, we can get a measurement on it. Okay, that's good. And the emitter is good. Okay, here's this one here. Another PNP. That kind of looks funky. It shouldn't be low like that. It should be around 0.6. Okay, what's going on this side? That's 0.6. Okay, so what is that? Q414. So let's write that down. You might have to pull that one out and check it. Okay. Not expecting to find a shorted transistor, because usually when a transistor shorts, it grenades the whole amplifier, and you'll take out several transistors. But This one's kind of suspicious too. 517, it's kind of low. Q412. Okay. Now let's try these ones. Base is over here, Q420. See if I can get in here. That looks kind of normal. Okay. And that leaves these two. Oh, that don't look good. Alright, so Q416. Now last one. That one looks okay. So everything looked fine, except for those three had kind of unusual readings. Now let's check the long tail pair. Okay. That's all right. Everything's good here. Everything's good there. So our problem, I'm going to pull these two and this one. I might as well pull all three because they're all on this heatsink. So I'll pull all those three transistors and these two, and we'll test them out of circuit. This one tested fine, didn't it? Yeah. And we could also have an open resistor somewhere too. So what I'll do is I'll go through and I'll check a lot of these resistors. This one's a 470. This one's a 22K. Alright, another 22K over here. Ohms. $1K, 220K, $2.2K, this one here is a 68 ohms, I think. $330. 33. It's a black, must be 33. 2.7. Should be 5.6. 680. Yep. And what is this one hiding here? Is that 100 ohm? Did I check this one? I think I did. Okay. Everything looks fine on the resistor side of things. What's going on with this? Yeah, it's going to have to be one of these three transistors. Could be this stebistor here. This thing, I don't know how. Let's try if we can get a reading on this. It should read like 2 diodes. Yeah, that's looks normal. I can check it with the other side. I can't even get in here. $1.97 blue. Oh, I had to read reversed. Okay, yeah. The other possibility is it could be a bad potentiometer. So what do we have here? This is VR402, and VR402 is, what is it? 100 ohms. That is the DC balance pot. Okay. This is 100 ohms. And then this pot is the bias setting pot. So what do we have here? Yeah, because it's in parallel with 66 ohms. So 100 ohms with 66 ohms across it will bring it down to probably 36. Okay. Okay. Now this one here is 500 ohms. So this one should be okay. Okay, that one looks good. All right, I'll pull those 3 out and then we'll test them out of circuit. Before I start yanking out transistors here, I want to check the outputs because I don't remember if I checked these or not. So let's go through these. Got a 2SB 690 and complement is the 2SD 726. And these are TO 220 package. Not very high outputs. Okay, so let's go here. Let's check the PNP. That's good. That's good. That's good. That's bad. That's open. Is that open? Let me lift that leg. Is that our problem? Right there is a bad transistor on the outputs. Let's see what we can do here. Okay. Try that one more time. Open. Open, open, open. That transistor's bad. That's our fault right there. 2SD 726. Now I don't have any of those in stock, I'm pretty sure. So we're going to have to figure out some kind of substitute for these complementary pair. Let me put my thinking cap on and see what I can come back with. Okay, to start, let's have a look at this Phono amplifier. I pulled it out to have a look at it. What's it got here? 7 pins and 2 mounting lugs. Now what I did is I pulled it out because this is totally pretty much blobbed with this glue. I cleaned most of it off. I left some here just to show you. This glue is a problem. Now when they use the glue to stick 2 parts together like this, that's not a problem. That's fine. That keeps the parts from moving around. Problem is when they start gooping it down around where the wires are, the leads, because this stuff can be conductive. And this is a Phono amplifier, and it's high impedance. High impedance, yeah, and low signal. So what I did is I unsoldered these two resistors so I could lift them out of the way, just like this, and then I can dig this crap out from underneath it. And yeah, you're gonna get current leakage through these. Oh, look at this. This is terrible. Eventually it's going to leak current and it's going to cause a problem in your circuits. So you got to pick at it and dig it out. That's what I've been doing here. Now, another thing I did is I yanked out a few capacitors and tested them. And let me tell you what I found here. Okay. So these blue ones are problematic. They all seem to be, these are Panasonic, the blue Panasonics. And I haven't seen any leakage on these. These are famous for leaking. I haven't seen any leakage on the bottom of these yet. Probably will once I get through the amplifier. But these 10 microfarad, 16 volts, they measured out at 7 microfarad. And they had high ESR, so I replaced these with audio grade caps. Okay. Same goes with these two. These were 33 microfarad at 10 volts. These are on. Oh, these ones are on the input. These ones are on the output. They're coupling DC blocking coupling caps, and these were high ESR and low value. So I replaced these two as well. And these two here on the end, these are power supply. Plus minus 15 volts, and they were testing high ESR, so I pulled them out and replaced them. These ones I pulled out and tested, they were fine, absolutely fine, so I left them. And this one I haven't tested yet, but I'm going to, and after I get this stuff cleaned out. Now, the reason I wanted to look at the phono amplifier first is because we had a problem with the phono amp, and I wanted to figure that one out before I started on the main amplifier. And here it is. I think I found it. Let's just show you what it looks like. Okay, I don't know if you can see this. The solder connection is broken here. It's cracked. Was it that one? Yeah, I think it was. But if I wiggle this transistor, I can see the wire wiggling. I don't know if you can see it. But definitely cracked here. So I'm going to solder this back up. And then everything should be 100% with this phono amplifier. I'm trying to use up my silver solder here. That's why it's so bloody thin, though I don't like using it. Yeah, as soon as I hit it with the heat, it came apart. So let's flood this. And I'll have a good look at everything else. Yeah, but this is a problem here, this stuff. So I'll pick all this out, and then I'll put the resistors back, and then this will be done. Oh, I still need to test that capacitor. And then I'll clean the backside. I'll scrub it down with alcohol and a brush, clean it all nice, and then we'll put it ready for reinstall. All right, all finished. No, not really. I'm joking. This came in the mail today, believe it or not, and it came at the perfect time too. This is another 350i that I ordered on eBay. I bought it more for being a parts unit more than anything else. It's pretty rough shape, and now that it got here, I'm looking at it, and yeah, it's pretty dinged up. Everything's here though, that's the good thing. You know, when you buy a parts unit, you want to have all the knobs there and buttons and switches, so that if you need to use it for robbing parts off, you can. So So I heard something rattling inside here, so let's have a look inside. Come on, let go. Okay, so here it is. It looks all complete. The power switch has some rubber bands on it, and it looks like it has been broken. That's kind of unfortunate because I wanted to use this stick on the other amplifier or the receiver. But okay. Looks like it's got high hours. Look at this. It's not even screwed down. Somebody was mucking around here with heatsink compound, looks like. Maybe they had the heatsink out, I don't know. I don't know why you would want to take the heatsink out. Yeah, so it all looks original and complete. My intention is to rob the power transistors out of this to put in the other one. Considering I have a few options here. The power transistors burned out, they're not available. So I have some 2SB 596, and I was going to pair that with a 2SD 526, and that would be a complementary pair. But these transistors here are rated about the same, maybe even a touch less than the originals. They'll work, but I don't know how well they'll work. Another option is I could use TIP41, TIP42, complementary pair, and I could just slap those in and use them. That would probably be a good option as well. And my third option is just rob transistors from this one if they're good. If they're not good, then I guess that's the end of that one. But yeah, I'll just take transistors out of this one, and then that way it'll have the original Japanese transistors in it, and I won't be making any unnecessary changes. But I'm just looking at this. It looks, yeah, nobody's monkeyed around except for this voltage regulator chip here, or transistor. It's a series pass transistor. This is regulating to 14 volts, I think, 12 volts, and this supplies the tuner and all that with power. So I mean, I don't know what they're doing there. Fuses are intact. It's a good sign. Maybe the main fuse is out, I don't know. I haven't plugged it in, I'm not going to. The main fuse is under here, and it's glued down. Let's pull the bottom off. So this is how I got it. It had these foam pads glued on. All the feet are missing. It had random screws, different types of screws, silver ones, machine screws, sheet metal screws. They were just random and they were kind of half put in. Some are missing. So yeah, somebody's been in here. Don't see anything weird. And oh my god, look at the mess this thing has. Let me show you. Check out these transistors. These are the original ones, but somebody's been monkeying around with some heatsink compound, and that's the gray stuff. I don't even think that's the proper compound to be using. If that's made for CPUs, that stuff could be conductive if it has silver in it. I think you're only supposed to use the white stuff for electronics. But yeah, it's a high hours unit. Seen a lot of traffic. Got some seniority. But yeah, like I said, this is going to be for robbing parts off of. So, and maybe you never know. I might decide to get it going, and I could do that later at a later date. But for right now, let's take a pair of these out. Let's test these two, and then we'll take them out. Alrighty. These two collectors good. Base 2 emitter is good. Everything's good on that one. Base to collector is good. Base to emitter is good. So these two transistors are good. You can take them out, clean them up, and we can slap them in the other receiver, and it should work. Alright, now that I've had a good look at this receiver, I can see, this is a common for a lot of these receivers of this age, cracked solders. Man, and man, they're all over the place on this. I can see them down here, there's a couple. Where was it? I'm going to get my head in the way. See one here. There's one here. You can see them all over. And there's some up here. This here is a plus minus 15 volt regulator. There's a whole bunch over here. I saw a few. There's one there. I think this transistor's cracked. Let's see, one here. Yeah, that's the problem with these. And then there's some down here. Is this a power resistor or something? I don't know. It's got cracked joints. That's I think this is going to be the demise of a lot of these receivers. These, not only the 350, but the 460 and a few other ones. They all have the cracked joints on these boards, and they're getting to be that age where if you don't attend to them, they're just going to get worse and worse. And then what happens is you grenade the amplifier, and you blow a pair of outputs or more because you have an open connection somewhere, and it throws the bias all the way out of whack, and yeah, it just self-destructs. So it's good to get the bottom off these things and have a good inspection. Cleaning first. You got to clean all this rosin flux off. Like, look at this. It's just really thick rosin flux. Now clean all that off and have a good inspection. Looks like somebody cleaned this because there's not much flux on this board. Somebody cleaned it, but they missed a whole bunch of cracked solders. Like, man, oh man. Okay, so let's get those out. And this is filthy. I might have to put some gloves on here. This might have to get tricky. I wonder if they even have, oh, there is an insulator under there. Okay, I'll pull these out. Yuck. Probably what I'll end up doing is at a later date I'll put those transistors that I'm going to sub, these ones here, I'll put them in and then I'll see how it performs. I'm kind of interested to see how my selected transistors will work. If they'll handle the power and the voltages and whatnot. It's not a high power amplifier, but yeah, you don't want it to grenade on you either, because some parameters out of spec. I don't know what's going on here. What a mess. What a mess. What is this? Okay. Alright, I got the transistors soldered in and everything's ready to go. Put back together. I did test those two transistors, or three, that I mentioned earlier, and they tested fine now that I put the new transistor in, the new output transistor. The right channel, I put it all back together again. Let's see here. These filter caps, these are 6800 at 35 volts. They feel really light, like they're dried up. And testing them they come back at about 5100, 5000 microfarad. So they're down quite a bit on value. So I opted to replace them. And a little different modification than I usually do. Instead of just putting in one large cap, I put in two smaller caps. So these are 4700s, and there's 4 of them now instead of 2. So there's a total of 9,500 or whatever microfarads, almost 10,000. So Harman Kardon actually left provisions on the printed circuit board for extra capacitors. So I'm just taking advantage of that. I'm using those holes and those traces, and I just pop the capacitors in and make sure they're orientated the right way around because it's not marked on the board. So this is all ready to go. I want to do a power on test, but I don't want to just hit it with the power switch and risk popping something else that I might have missed. So what I'm going to do is I'm going to bring it up slowly on the variac. I have a voltmeter connected across both emitter resistors on that channel. So if current goes crazy and out of control, this needle will also indicate that. So we're going to watch that needle. And I'm going to bring it up slowly. I got it set up for AM, I believe, and I got the volume turned up. There, we have both channels. We're at full voltage. That's our biasing current for the right channel. We have about 65 millivolts, which is kind of high. But that channel was running hot. I remember when I first tested it, it seemed to heat up fast. So that's probably the reason why. So let's try this one. This one's up around 75 millivolts. Let's see if we can tweak some of this. Turn that one down. We'll set it to the proper value later. Just getting it down so it doesn't overheat. Down to about 30. All right.
Bye. It's now at Mike million.
One arrangement. And so our united demand is for a 35% federal portion of
left channel,
that would
right
increase
channel.
Alberta's share of the Canada Health Transfer by about 3 point. Is acceptable. The problem. No, 3-to-1 arrangement. And so our united demand is for a 35% federal portion of health funding. That would increase Alberta's share of the Canada Health Transfer by about 3.25 billion.
Okay, so everything's working. At this point, I've done nothing to the tuner. I've recapped the tone board and preamplifier board here underneath. I've done nothing with the switches or pots because they are clean and they sound clean and they seem to be functioning normal. I recapped the power amplifier. I recapped the power supply. And next I need to do lamps, and let's do a power test first just to make sure that we got the power amplifier finished and is working good. So let's hook it up and put it through its paces. All right, we got it all back together, and I'm going to give it a test. I'm going to hook up the speakers, 1000 hertz tone coming into the auxiliary. So let's turn on my isolated power supply and turn on the unit, and I'll start going up on the variac. And we should see we should have sound here. And there it is. Left channel, right channel. I still have a buzz. Left channel, right channel has a buzz. Well, let's get a scope on here and see what's going on. Okay, I got a scope hooked up to channel B. Here's channel A. Shut the speakers off. Turn on speakers. Hang on a second. What happened there? Why am I getting speakers B's shut off? Why am I getting a signal through there? Shouldn't be. Anyways, let's go. Here we go on speakers B. Gonna turn it up, and we have a clean sine wave both channels, right up to clipping. And I don't see anything wrong with that signal. So maybe there's something going on with my speakers. I'm hearing a buzz though, a harmonic on the right channel. But it looks clean on the scope. So here's a look on the scope of the FFT function on the oscilloscope. Right channel I'm looking at. So if I increase the amplitude, you can see the RMS voltage coming out. I have no load on here whatsoever. So this is if I keep increasing it, it all looks very, very clean until I get to the point of distortion is right there, and it's 16, 18 volts, and that is clipping coming into action. So that looks very good. Let's try the left channel while we're here. Just change leads. Plug in the left channel. Do the same thing. Something's wrong here with the left channel. What's going on? The balance is set. Yeah, I just had my probe on them wrong. Okay, I got my probe set right now. So let's go left channel. And same thing, same results. So they both look balanced and functioning. Okay, we got it all wired in for a power test. I'm gonna plug it into the wall, going straight in, turning it on, and let's see. Speakers 1, we have our tone. Now it sounds clean on the right channel. I don't understand this. I was definitely hearing its distortion earlier. Could have been my connections too. Okay, let's go speakers B. Start turning it up. Get full power. There's clipping there. Back it off a little. Right off to this point. And we got 14.33 volts RMS. So I'm going to let this go for a while and see how it warms up. I can't remember what the spec is for this amplifier. Is it 25 watts per channel? I'm not sure. I don't have it printed off. It's not a high power brood anyway, so we let it cook for a while. Let it warm up. I'm just flirting with the clipping here. It seems like it's symmetrical. It should be good. Okay, so I'll just let this go for a while. Okay, we've been on full power for about 8 minutes now, and this is starting to get warm. It's starting to get hot. This is definitely hot. This is starting to get too hot to put your hand on, but I think it's proved its point. So we'll shut her down. You can also do the square wave test, see how this thing behaves that way, but I expect it'll be good performance there too. So let's try this. And up it comes, and it looks perfect. A little bit of, let me try the controls. Is that bass? No, this is bass. Bass treble, bass boost, bass cut, treble cut, treble boost. That's kind of sad looking there. It's an interesting way of boosting the treble. Huh. Okay, balance. It's nice and clean. This is the stereo pot. It doesn't really do anything on a mono signal. That is a nice clean square wave. Yeah, it's pretty good. Let me try this. Pretty good. I'm going to leave it at that. Okay, so I got a few more things to do. Have to change a lamp on the dial, in the dial face. There's one lamp out. I replaced the dial pointer lamp, but I still need to anchor the cable down. Test out the tuner yet. I don't know if I've done much testing on the tuner. I've tried it out and it works. So we'll get it all back together, finish it up. Got the phono stage back in. Let me test the phono stage before I put everything back together. So let me reconfigure this. Okay, I'll switch to phono. Turn it up. I'm feeding it a 3 millivolt signal. Let's turn this up. Looks like we're getting some hum here. More signal. 10 millivolts. Into clipping. We're getting a bit of hum because the covers are off. I think that's what's going on here. But it's working as expected. Okay, well there it is, back together. Let's give it a scan through the FM band and see what we can hear. The tuner actually works pretty good. I didn't do anything to the tuner at all except for cleaning the PCB board. It pulls the signals in pretty good. Stereo separation is really good. It does have a lot of background noise, but I think that's just my environment and my lack of a good antenna. Yeah, it's picking up all the way up to the top. Let's go to the top of the band. Nice strong station, it's very quiet. So yeah, it's working great. Looking forward to giving this one a test drive. I'm kind of curious on how it sounds, especially since I have one I just bought on eBay, and I don't know, I'm kind of torn on whether I should fix that one up or just use it for parts, because it is missing the AM antenna from the back. It's got a few nasty dings on the front, and somebody robbed the transistors out of it. So anyways, that's it for this one. Thanks for watching, and see you in the next one. Take care, and stay healthy.